is the script.
Okay.
It's the static script. The script doesn't change, right? It's really the book from which everything is derived, the repository of information, whereas the proteins are really, okay, well, they are the spoken word coming from the actors. Right?
Okay.
Proteins are the actors of the biological world.
Okay.
DNA.
So the proteins are the expressions of the genes from the DNA.
Exactly.
Okay.
Exactly. That's very good. That's a very good way to put it.
Okay.
And we say exactly that. Proteins are expressed from DNA.
Okay.
So yeah, that's a good distinction there. So we really, we are kind of at the maturity, I wouldn't say the zenith of the genomic age, but really we're mapping entire genomes now. The price of mapping a genome,
I know, it's ridiculous, right?
So we can kind of
the first one was like $8 billion or something, and took like 9 years, and now they do 52 in an hour and a half for $100 in a lab or something.
Exactly. The technology, this is one of those areas where the technology has just like moved exponentially faster throughout the last 20 years, I would say.
What is it that we're like? See, I've done the team thing.
You're part of humanity.
That's
right.
I'm a human.
Yes,
almost.
I can take credit for this.
What is it that you learn from mapping the genome? What, like, that research, as you're trekking down those fields, like the little bits that I know, the one part that I was like, I'm gonna argue with the guy who knows stuff and I don't. But like you said, that DNA is being a script. The only thing I know about DNA is that it does change. Like, that's the only thing we're looking for is the mutations, and I'm probably talking way out of my. But like, every time you copy that DNA, the idiot making the copy makes a mistake. And however many times that mistake gets copied, if it doesn't kill you before you reproduce, it moves on.
Yeah, well, so kind of you're right, you're absolutely right in many ways. But the normally DNA, the idea is that it's a static repository and it doesn't change. And when it does change, that's when we come up with real problems, especially at like the germline level. You can have somatic mutations that kind of change things and can lead to cancer, and but germline mutations can lead to super serious diseases. So mapping that out is kind of knowing what's there. How has the change occurred? What is the actual change? But then understanding how the change actually alters biology is an entirely different question.
I'm very much guessing here, but I'm guessing something like this is being dangerous by getting specific, but say like Huntington's disease, because it's the one they talk about when they talk about this stuff. I almost imagine that once you have that piece of information in the script, the way that it expresses itself changes dramatically based on the individual that has that issue, even though it's doing the same thing. Does that...
No,
am I overcomplicating?
I think there's a little bit of there's a degree of you can harbor a mutation and it not be expressed.
Okay.
So it doesn't cause a problem. But these diseases, I believe Huntington's also I believe it's a monogenic disease, like cystic fibrosis. These diseases that come from very specific changes in the genome at in a specific protein often. So that in those cases, once that's changed, it's the same. That's why, cystic fibrosis in one person manifests very similarly to. And
that happens more in the protein than it does at the genetic level?
Well, it happens at the genetic level, but the genetic level dictates the change at the protein level. So for instance, cystic fibrosis, I believe it's a chloride channel that's involved in mucous membranes, and so when that chloride channel doesn't function properly, you get an imbalance in the ionic state within the cell, and then the mucous membrane change, and that's why they have in their lungs often will accumulate mucus, and it becomes very hard for them to breathe properly, and so it manifests. Some of these are simple.
Sure, of course. If they, I already was lost twice, so thank you.
But it can, then we get into the complexity. You know, one of the most interesting things is as I went through studying at the university level, I studied immunology, and that's when my mind was kind of blown. You have this complex system, and one of the revelations I had during that time is that you will have cancer 20 times potentially before you actually develop cancer.
Okay.
And your body's simply capable of addressing that, surveying, detecting, and then eliminating that cancer before you actually, you know.
I had no idea.
Yeah. Well, this is you know, one of the major the Nobel Prize in medicine. One of the prizes was given out for this idea of these. I'm going to get too deep into it here, so I'm also going to pull us back. But exhaustion markers, and in the immune system, where it's kind of the brakes get put on the immune system after a certain point, when it's just like, okay, we can't deal with this.
Doesn't have the
anymore.
energy to keep. Okay.
Yeah, like for instance, a cancer that just keeps regenerating, the immune system's like, okay, I thought we dealt with this, and then after its time, it's like, okay, we can't deal with this anymore. So one of the major discoveries of the last 15 years or so, and they gave out a Nobel Prize for it, is that there's actually molecules in the cells of the immune system that essentially put brakes on the immune system, and if you can block those, you can take the brakes off.
Okay.
Of the immune system, and basically reactivate the immune system to deal with cancers. And they've had some like really groundbreaking developments. Say for instance, it's a form of skin cancer, serious form of melanoma. Exactly. It's very difficult to treat.
Right.
But with this basically new development, they've had some very striking results. So it's like this.
Is that the research you're involved in, or is that just research you're aware of?
Research I'm aware of and loosely involved in.
Okay, so what?
That'll do it for this episode of the AVB Podcast. Don't forget you can subscribe to our full audio episodes on Spotify, Apple Podcasts, or anywhere you find your audio podcasts. The full episodes, highlights, and our live off-the-floor performance videos can be found at our YouTube channel, and you can follow us on Facebook and Instagram at the AVB Podcast. Of course, you'll find links to our incredible sponsors and this week's guest in the description below. The AVB Podcast is part of the Border City Network. Find more great content at bordercitynetwork.com. See you next time, folks. Bye-bye.